going to give us an overview of what's happening at Suzuko, and you might introduce your colleague and maybe give us an example of the kinds of clients you work with.
Right. Thanks, Alan. I'm Adrian Trend. I'm the CEO of Suzuko. We are basically a Swiss-based consulting company for linked data. We exist for like 5 years now, and we basically started with classical linked data consulting, then won some big tenders from the Swiss government. That's basically what I will show you today. And we are also moving more and more into enterprise because obviously, as probably all of you, we are very convinced of the RDF stack and solving problems on top of it. And what I would like to show you today is a bit some parts.
By the way, I'm sorry to interrupt. Melissa, can we start recording here?
Oh yeah, sorry, yeah.
I want to make sure that didn't capture this because some folks won't be able to join on time.
Yes, I got it.
Thank you.
Good. So I will show you a selection of stuff we do. I don't think there's so many things we do that sometimes I even forgot what we did already. Thomas will probably talk a bit more technical details later. Thomas is our CTO. We are quite decentralized to give you some ideas. We have some people in Switzerland, some people in Germany, France, Poland, and one lonely person in the States. But we pretty much work decentralized, so we don't have a real main office where there are many people. We are not more than 2 people in the same room at the moment. So we work very decentralized, and our clients are mostly government and enterprise within Europe, so not just in Switzerland as well. What we basically try to do is, we did a lot of research projects before. I came from the so-called FP7 projects. The Europeans of you might probably know that. These were very big research projects from the European Union. And in there, I twice or even 3 times tried to build the magic thing to rule them all. You know, this kind of application where you can do everything in one single interface and magically everything will be solved, what you had as problems. And after 3 of these projects, we basically came to the conclusion that's not going to happen. That's probably not how RDF, in our opinion, will be the most useful way. And then we started to take a step back and we said, okay, let's think about building blocks and not the one-size-fits-all solutions. Let's try to work with RDF, create RDF, and then slowly but steadily extend in what's basically missing, that we can make our own life easier. And right now I see Suzuko a bit as a company which helps other companies enabling solving problems with RDF. So while we do have some products, most of the things we actually do are more like libraries, abstractions. One of them I will present to you, so you will get a better idea of how we think. You can even remember, Alan, when we first talked, maybe a few months ago, I think. We had a chat about how we think, and Alan then told me you must have read Dave's book, Data Center, which I never heard of before. So meanwhile, I did read it, and I was really, really happy to see that there are other people out there which do think in the same way of abstraction.
It has had that effect.
Exactly.
And you had some clients or other organizations in your area that appreciated the book as well, I understand.
Yeah, absolutely. So basically, I mentioned that last time in the call. We started to mention that book. We have a few high-ranked government officials which read the book and which are really like, they were so happy to read that stuff, because I think everyone with a longer IT history can relate to the problems. And obviously some of these government people did talk to me before, so they were a little bit infected with RDF, but it was a really long process. So before we founded Suzuko, I already started like annoying people at the government about that this could solve some of the government's problems, and later we got some small projects, and now we have really a platform. I will show you basically what we started building for the government, and this is only the first step of hopefully many more steps where we can solve stuff with RDF. But slowly but steadily, we really see that it starts to hit a nerve within at least Swiss government organizations. They see that there is a big picture behind it. I'm not sure if you guys saw the keyword from Dan Brickley, famous Mr. Faux. He wrote in a book that people think that RDF is hard because it's complex, or they think it's complex, but it's actually not RDF which is hard. RDF is like super simple from the model, but it looks hard because we try to solve really hard problems with it. And I think that's what these people saw as well in RDF, and with Data.com's it really helped them telling the story, because they see they are not allowed. There are other people out there which try solving that. So let me quickly give an introduction about the platform. So this is basically the official entry point from the Swiss government. And the project is called LINDAS. It stands for Linked Data something, which I forgot. It's basically a hosted Sparkle endpoint. There's a cluster, or there are actually 3 different clusters: a test cluster where people can just play around, an integration cluster where data starts to be published in, and then a production cluster which should be used for building applications on top of it. So what the government, after a pilot project which started, I think, in 2014, decided was that they have to do a real tender for that. This tender was in 2018. We won some part of the tender. There was basically a part where they do the infrastructure. That's not us. We are not infrastructure people. There is a part where it was about creating a pipelining system. This is what I will present to you. That's the one we won. And there is a part about visualization on top of it for the Environment Agency in Switzerland. I will probably show that a little bit as well in the end. So
sounds good. I think somebody in the background here should be on mute, making some noise.
Right, there are still a few not muted. If you're not talking, maybe you can mute yourself. Yep.
Appreciate it.
Good. So the interesting thing was that this tender was quite.
So sorry, before you start, can I ask? Is it possible to make the screen display a bit bigger? It's the text is coming out very small on my screen.
Better like this.
That's better.
Good.
But if it could be wider too, that would be even better.
Okay, let me know. I already improved some of the screens. If it's still too small, just let me know. I can zoom in. So the interesting thing of this tender was that they explicitly tried to tailor it that smaller companies will win it, because I'm not sure about other countries, but in Switzerland, usually it's always the usual suspect of really large consulting companies winning tenders because they have the resources. And they did the tender in a way that basically the large companies had a really hard time applying, which I found super interesting. And they wanted that because they said, we don't think that we will find the linked data innovation in large companies. This is more something for specialized companies like ourselves, which, you know, how it is with disruptive technologies. The big ones are usually a bit slower there. So we won the tender, and the other thing was that they said all the results developed in this tender need to be open source. That was the first time the Swiss government said the results are available for everyone. So everything I show you today is available on GitHub, public repos, MIT licensed. So you can use whatever I will show you here today, I think with one exception right now. And if you're unsure, just let me know. I will probably also send out some links at the end of this presentation, so you can have a look at the stuff and play around with it on your own. So the first step we had to do, we had in the pilot project, we were already involved there. We did some proof of concepts to translate non-RDF data to RDF. The one which I will show you, which was really one which worked really well for selling as well, was the Environmental Office of Switzerland. They have the job from the government to publish this data to the public, and by now it's pretty much clear that they have to do that as open data. So what they obviously did first is they published CSV files, they put it on the web, they made it available in CCAN, and people could start downloading it. And we then took this data, transformed it more or less elegant to link data. We use the RDF data cube vocabulary for those of you who know that, which is really well done for like tabular data. Everything you can represent in multidimensional tables can be described in RDF data cube. So you can do really powerful slicing and dicing as well. So we did that. We did some other projects. We had data from public transport. We had data from the government itself about who works where, a whole bunch of data. We did this pipelining on Unix systems. We built some scripts. We started to use some tooling which was out there. And pretty early we saw that the problem of the open source tooling, which was the stuff we were interested in, was that while you get basically a tool for everything, the tool quality is a different thing. So as usual in domains where research was quite strong, you will find tools for everything, but the tool quality is really horrible sometimes. So as soon as you started to use a bit bigger data sets, the tools didn't scale anymore. You couldn't do streaming and so on. So it was pretty clear that at one point we will have to build our own tooling. Then Thomas and I started to think about that. We had a pretty good idea on what it means to transform data to RDF, and we basically started thinking about how far should we put the abstraction. Like, do we need something like OpenRefine, where you have like a language like GREL, or however they pronounce that, the Google Refine language, where you can do manipulation on strings? Should we have very generic components only? Where do we draw the line? And what we basically came to the conclusion is we will not rebuild a programming language. And we were also quite convinced that at one point you will need to program stuff when you need to clean up data. Every one of you who already did that with large data sets know what I mean. There are always some weird things in data you could never have imagined before. I'm always amazed how much you can screw up CSV data, for example. So at one point you want to be able to use the expressiveness of a programming language. But on the other hand, you have things which repeat all the time. I mean, when you have RDF, the final result will probably be stored in a triple store. You want to write into graph store and just load the data in a triple store. Data sources, there is just a limited amount of data sources you have to interact with. You might have to get data from an FTP server, from a WebDAV server, from an S3 bucket, whatever. So there's not an unlimited amount of things you need to do, and these things we could probably abstract. So then we started thinking about the design. This is an older presentation I did at the Open Data event in Switzerland. So the whole idea of this Linux platform is really that the government provides highly valuable open data, not just CSV files. We want to link the data. We want to have the networking effect in the data. We don't want that people have to put the CSV files into their own SQL databases first before they basically can start doing stuff. And obviously linked data, RDF, is the way to go there, and public Sparkle endpoints as well. So share and reuse. If you transform data, you have to do the whole thinking. You need to understand the data. If I did that, it will be easier for the next one consuming this data. They don't have to redo the data over and over again. And obviously, the more data, the more networking between the data, the more users you will attract, because you can do really, really powerful stuff on that. And then another thing, we really wanted to reduce costs for the participants as well. So when a new government organization starts, they don't have to think about the triple store. They don't have to think about the pipelining. They can use the infrastructure provided by the Swiss government itself, and they share costs. So every new customer in this government organization contributes one part of the running cost for this platform. History is not interesting. As I told you before, we have a cluster. It's actually a startup cluster, 3 nodes each, and we have 3 of them. It's completely Kubernetes backend. This is the part which the infrastructure company is doing. We have a test system, an integration system, and a production system. For the pipelining, you will see that soon. We decided to use GitLab. There is a integration in GitLab. GitLab is also open source, so you can host it yourself. And what Thomas and I pretty early came to the conclusion is that we want to treat data pipelines like other people treat code. So when you have a pipeline which does the continuous integration for your application, for your code, we want to do the same with data pipelining. I will show you what that means. Just a little bit about the architecture. We have web interfaces which are tailored at the people using it. I will show one of them. And basically the big work first, so in the last year, we mainly worked on this part here. We thought about the data publication pipeline, which will then run automated in the GitLab instance, and it will write the results to the startup Triple Store. The web application, we built some other people built some, so I will show you a bit what this means and where we are going in this year. So what were the goals of the pipeline? It was absolutely clear for me that every one of you who worked with the Link Data Cloud, there is a ton of data in there, but there is very few data which is actually up to date. So it was clear for me that we want to ensure that the costs are close to zero to recreate the data. If it means work, if it means updating libraries, if it means doing something manually for updating the data set, people will not do it. So the more you can automate, the better. That's probably the only way to get up-to-date data. And then I mentioned it, it's basically DevOps for linked data, in my opinion. We treat data like other coders treat code. It's automated, you can reproduce everything, and that's the goal for every single pipeline. And then we came up with the engine. We will show you that. So basically, we described the pipeline in RDF. I will show that later. And then Thomas implemented an engine for interpreting this pipeline description. So the pipeline description is completely in data. It describes itself in data in RDF. And Thomas implemented the pipeline engine in server-side JavaScript, also known as Node.js. The reason here is pretty simple. We think that JavaScript is right now the most popular language in the web. You can attract the biggest crowd in that domain, and if you want to make that whole thing a bit more common, that's a good starting point. We can later talk about other languages. There are some ideas and some implementations in other languages as well. As I said, the pipeline itself is described in RDF, and the environment we run it is completely Dockerized. So I will show you the thing on my disk, and I will show you how it runs in the CI pipeline. You can really put that in a packet, in a container, in an image, and you can run that wherever you want, in an intranet, in a CI tool like GitLab, on your local disk, on Windows even, it totally doesn't matter. Okay, so I would like to show you basically the abstraction first. You interrupt me when you have questions, and after that we show you a bit what we did in the front end and where we are going. So the pipelining system is called Barnard 59. That's basically the working title. That's also the name of the libraries. Again, I will send you the link so you can have a look at that. Here we describe a bit the concept, how this works. And when you go to the wiki, there is a primer which basically walks you through a simple install example and shows you what you have to do to get the first things working. Maybe to give you an idea what we support right now, we have some core stuff. These are basically the core things implemented, which provide the base functionality. And then we support protocols and formats. So for example, here we have support for CSV on the web standard, JSON, LD, and ntriple, so you can parse other data, JSON-based data, CSV-based data, and so on. We can execute Sparkle queries and do stuff with that and integrate it in a pipeline. We have one part which executes file-based TDB Sparkle endpoint from Apache Jena. So you can also do some inference in the pipeline. When you want to create new triples, you could do that. We can get data from FTP. We can write to a graph store. We have a Kafka connector. We have MQTT support. We have support for some statistical data formats popular in Europe. They are called PX cubes. You can even execute standard Unix shell commands. This is always very nice. There's a lot of stuff you can do in shells. And obviously, we can fetch stuff from the web. So when we basically have a new requirement and we have to do what we didn't do yet, we simply implement a new operator which adds this functionality, and then you can basically plug it to whatever you want. So let's have a look at one concrete example. As I told, the pipeline definition itself is data-driven, so it is really RDF. This is a relatively simple pipeline which takes a CSV file, transforms it based on CSV on the web mapping files to RDF, and writes it into a file. This example is complex enough that you get a bit the idea, but it's still readable. As maybe one note, I will show you now triples, but we already have a basic interface where simply the triples fall out, so you don't have to write that manual anymore. But if you are okay with Turtle, you can really write that manual. So we have the prefixes, obviously. We have some variables, so you can parameterize the whole thing. You can also pass them on the command line, obviously. You can have multiple configurations and pass them to multiple pipelines. It's extremely flexible if you want to change things in your pipeline and do things a bit more dynamic. In a pipeline, you need at least one pipeline. This is basically the entry point where you say, okay, have a look at the tasks you have to do. And as a side note, it's not in this one, but you can have sub-pipelines. So if you have some tasks which you always repeat, you can move them to a pipeline, and then you can call this pipeline from the entry point pipeline. So you can really change chain things, and you can reuse standard patterns which you use all the time. This is extremely valuable. This pipeline, we say we have an input file which we call metadata file. This is the JSON structure from the CSV on the web standard which we use here. And in the end, write the file to output in this and triple serialization. And then in this pipeline, we have this kind of steps: read file, decompress, parse, filter some stuff, convert some stuff, serialize, and write it to a file. Interesting thing is, after this step, correct me if I'm wrong, Thomas, after this step, you get an n-triples, basically an RDF stream. So we don't just pass text around. Up to this point, it's a textual stream. And from here, we have a quad stream, which is really a quad structure in JavaScript, and you can manipulate, you can have filters on quad. I will show you an example. So read file, you then see that this is using a node library to read, to create a read stream. It passes some arguments. This is part of the base functions of the pipelining. It will read the file. The file in this example I will show you here in the input is gzipped, so we have to have a step which unzips it. This is also one of the base functionalities you get with the pipeline. You can unzip it. Then every step passes the stream from its own step to the next step, basically. In the parsing step, we use the CSV on the web parser, which we provide, and we give the metadata, which is basically the information about how it should translate that to RDF. Again, that's based on the CSV on the web standard. Then here we have a small filter, and here you now see what you can do when you need to do stuff on your own. As a side note, it's now inline JavaScript, but you could also put that in a JavaScript file in your file system and then load it like that. So you can really use any JavaScript editor for editing it. What you get is, as I told you, at this step, it's basically quads from the parse step. So the filter not CSV step doesn't get a textual stream anymore, a quad stream. So we can access the quads and do something with the quads itself. And in this very simple example, you see it checks what's the predicate value. Does it start with that prefix? If so, return false. And we have a second check. We check if it's type and CSV on the web. And then we also return false. And Thomas, if it returns false, we throw away the triple, right?
Yeah, so this is to skip all the metadata from the CSV on the web parser.
Right, the CSV on the web parser by default creates a lot of metadata information which you usually don't want in the final data set, so it's a simple filter. I will show more complex filters later as well. So the filter step here simply throws away all the quads which do not return true, right, Thomas?
Yep.
So it's a very easy way to get rid of quads. In this example, we apparently had to fix the decimal thing. It's a comma, and we need to replace that with a dot, and then it's proper RDF. Otherwise, it wouldn't be valid XSD decimal. So you see, when you have special things, and you almost always will have some special things, then you can really easily add them as simple steps in the code. Oh yeah, and you see, this is no longer, this is now a map function. The map function doesn't throw away stuff, but you can actually edit the stuff and then return the updated quad. So you have full control over what you really create in your data. You can also create additional quads here. So we have pipelines which collect a bunch of things, then from one line basically create 5 triples or 5 quads and return 5 quads instead of just the one single quad they were. That's really nice when you need to split strings because they had like a lot of information in the data field or something like that. And then last but not least, we serialize the thing to n triples because we want to write it in a file, and then we write it to the output file. So that's a simple example of a pipeline. Now let me simply show you how I run that. This pipeline, by the way, is here. Again, I will send you the links. You can try that out. It's public. We can clone it on GitHub, and then all you need to do, I told you our implementation is running in Node.js. Let me quickly take that away so you really see. That's basically what you would have when you check out the repository. Then you do npm install. You'll install the dependencies, and it should have created an output field directory. Yes. So now I say npm run. It shows me that in this pipeline I can do two things. I can convert cube and stations. Let's try the first one. And now basically reads this turtle file which you saw before, executes every single step in there, gives you some logging, and it's already done. Let's see output. Now we have a file here. Let's have a look at that. So this is the n-triple file we just created from the CSV input. And that's basically already the whole magic of the abstraction. As you can imagine, it took us a while to get there. We had to try and retry some things. We had to make sure that you can debug the stuff as well. When you get stuck somewhere, things go wrong sometimes. You might not get proper data from whoever should send you data. You need to have some more validation and so on. But in the end, that's the principle of the pipelining, and it's all described in here. So before I go to the front end, any questions for that?
Any questions for Adrian? You can unmute now if you'd like to.
No questions, but it's very cool.
Okay, thanks. Anything else? Otherwise, I would show what we did next.
So Mark, any other comments on this? Have you seen anything akin to this out there, or pretty unique in some respects?
I mean, in terms of that level of pipeline, I have not. Doesn't mean it's not out there, but I haven't seen it. I also like, I do. It's just kind of fun to see the configuration in terms of Turtle. I know Jenna made a practice of that. You see a lot of continuous integration and deployment stuff uses like this YAML stuff, but I got to admit, when I first looked at that config file, my eyes, of course I'm used to seeing Turtle, but it kind of looked like YAML. It looked pretty easily self-describing, even though not a lot of people, really know Turtle compared to those who know YAML. But yeah, just the fact that it's, I like that the configuration is in Turtle. I like it seems very descriptive. Again, having never seen this before, I can look at that pipeline and pretty much tell what it's doing. So yeah, I think that's great.
So I now have to admit that it's really great that it is RDF, but believe me, you don't want to write this turtle, because the problem is, and that's something Thomas and I now reflect right now, because that's the next thing we want to build. We want to have some support, and we thought of several ways of where we could do that. So when you write turtle like that, you want to have some shapes which validate if your pipeline makes sense from what you do. So I talked before that some steps, so these steps here, they return a textual stream till the parse step. And from this point on, you get a quad stream. So you cannot have as a next step, a step which cannot handle quads.
Right.
Right now, there is absolutely no support, which basically tells you like, hey, sorry, this step does not fit for what you're trying to do. You get a different output. So that you now need to know, or you need to read the error message you will get and then see like, oh yeah, right, that's not quad stream. And here we have two ideas. So we have a proof of concept from a web interface where you can click the stuff together. And the cool thing is it's RDF. So every single step describes what it expects. So it's very easy to have tooling which supports you in just connecting things that actually make sense.
Yeah, that sounds super useful. One of the things I guess I was going to ask, I mean, there's two ways to diverge. One of them is, have you considered something like a YAML way to configure this as well? But then the other side of that, just because it's more familiar to people, but again, RDF people using this system should be fine with the turtle too, especially if you add that validation.
I think
yeah, go ahead.
I have like some mixed feelings for YAML. Somehow I really like it as long as it works. YAML is really hell when it doesn't.
Yeah, agreed.
So I've seen recently a YAML which generates RDF in the end. So that's maybe something to play with once and see if that actually works. But in the end, I show you now RDF, but I don't think that's the way we will really maintain the pipelines in the end.
Right. So something may translate to this.
Yeah, I think it's much smarter to invest time and money into other ways of creating these pipelines, and then just enjoy the fact that we could serialize it to turtle when we want to. But the purpose is that we can really, I mean, we have a graph. A pipeline is in that regard a graph which has some sequences which is parameterized, and it's really cool because you can now already deduct a lot of information for the machine from that configuration here. Honestly, my ultimate goal would be that when you have some input files and you already did a lot of stuff, so machine learning helps you creating a pipeline on the fly, and you just fix the stuff the machine didn't figure out. And then it's extremely useful when you have RDF, because you can really get all this meta information from it.
Yeah, exactly. That was actually my next comment, which you've kind of addressed, and that is, the value. There'd be an awful lot of value if these configurations are something you either want to query or you want to generate from metadata, right? Absolutely. Because I mean, you're not going to do that with the YAML, but with all the cool stuff in RDF, you could do construct queries or whatever to construct configuration based on other metadata, which would be really cool. And I think, and the other thing would be you could analyze your configurations through queries and things, which I don't think you can really do in YAML very easily. So.
No, totally not. And that's exactly where we want to go. So this is basically the first step, and basically the most uninteresting step. The cool stuff will happen the more pipelines we have, the more operators we have, the more front ends we have for this stuff. And I don't think there will be one single front ends. There will be different front ends for different kind of users in the end.
That's cool. And then the last comment, and I don't know how much you've been following the data stuff that Dave's been talking about, but again, the more of the aspects of it that are in the store, right? So, and this is just another example of pipeline configuration can be just another part of what's in the store, right? So yeah, this able to mix metadata and data and actually almost, I mean, it's kind of, but kind of code to say, here's how to configure things. The fact that if all that's in the same format is a lot of power.
Absolutely.
Yeah.
So cool. It's nice for a change to talk to people who actually think a bit further, because when you show that to government people, they get the point, but they don't think of all the cool things you can do when you have the foundation. And the foundation is really a tough sell initially.
Yeah. Yep. Yep, but I like it.
Great. So
Looks good.
let me,
Yeah, a lot
let
of
me
power.
quickly show like one interface, and I think it would be cool to have like maybe 10-15 minutes of discussion after that. So for the environmental office, they figured out that in many cases they don't have much more than CSV files or Excel files where they collect their data, which is the sad reality in many places, I think. So it was absolutely clear. I mean, there is no freaking way we're going to explain them to write turtle files like that. So we started working on a generic user interface, and then we saw that this is probably still one step behind what they need, because the output for the environmental office in all cases will be RDF data cubes. So we said, okay, let's make an interface which triggers a pipeline in the background, and we just collect all the information you need for basically creating RDF data cubes from CSV files. So what you see here, again, this interface is also open source. It basically collects all the data you need to collect for creating RDF data cube pipeline, which will be run in the background afterwards. So as a data owner, you can upload data. I hope I didn't take the big file now. That would take a while. I have a small version. In the backend, it will load the data in an S3 container, but you can also run that on your local file system, or you could integrate whatever other storage system you need. So this is basically what they have from Excel. And this is the data set from, it's called Animal Pest. So one of the organizations in the government has to publish all infections from all animal diseases which exist. So I've mapped this many times. I will just give you an idea. I need this field, the date. This is just a repetition of the date, not interesting. I need the postal zone. I need to know not the label, but the ID, the reason, how many animals were there, how many were sick, how many were infected, and how many died. That's basically what we want to publish. So now I have a first selection. We call this the fact table. We took this wording from cubes, from data cubes. So we say create a temp table from the selected columns. And as I said, this is the facts. This is basically the measurements we do. So we call this Seuchenmeldungen. It's the German word for animal disease. And now I won't go into details, but you could do fancy stuff like, let's say I want to say schema identifier here. It does autocomplete to existing schemas. You can change obviously how many animals died is not a string. This is actually an integer. So let's go and say it should be an integer. When you have language tag files, which is very common in Switzerland, we have 4 official languages. You can add the language tags, and everyone is super happy because it's really a tough sell in SQL. So I saved that, and it basically now creates, it stores this information. This is, by the way, also all stored in RDF. It's a hypermedia-driven API which writes to RDF, and the API is also described in RDF. That's something I will show in a few months from now when it's a bit more mature. And now you can see that, okay, these fields were already mapped, and I can have a different view where I really see that's basically a subset of a table I created. The cool thing is people which already work with relational tables, they are really, really fast in that because it's a similar process. They are used to what they would have to do when I wanted to do that in Access. Let me quickly switch to finished project, so you see a bit the bigger thing. So this is now basically a fully mapped example of the animal pest. So we have the fact table, and then we have some additional tables which contain the taxonomy of the diseases, the animal types, whatever you can think of which is in this data. And it's also linked, so you can link the data like you would link them in a relational database via foreign keys. So it basically consists of the mapping which we manually did before in a nice interface. And I mean, what we generate out of that is the CSV on the web standard, just to show you how it looks like. Basically creates this as output, this is CSV on the web. So that's basically what we wrote here manually. Here we did it really by hand, and here you generate that. And you can also preview the data. You can basically already tell me, like, show me how this particular table looks like in RDF. So now it will quickly take it. It runs, by the way, the exact same code. So it goes through a CSV on the web mapper, which we wrote for the pipelining. It's exactly the same thing. And okay, here with blank notes, but you get the idea. This is basically the RDF which falls out. What we then do, we have a generic pipeline which is capable of reading out this from the store. So I can specify in the pipeline, I have a command line tool for that as well. I can basically say, go to this particular project here. And then via the Hypermedia API, it can read out the configuration. It will get all these CSV on the web files. It will get an information of where the data is actually stored, in which S3 bucket, and then it will process it. So I can go in here and say, trigger a job, and now it will trigger via the GitLab API a pipeline. And let's just go in here. This is now the generic pipeline project. So you see, I'm in a GitLab project here. I'm in the CI/CD, and I just had a job started. And now I can basically see it will spawn a new virtual machine with a Docker container, which is a generic Docker container we did, which contains everything you need for RDF, including our tooling, obviously, and it will run the whole thing. Takes a while, so I will show you the last one. I think this is this one. So when you go here, it looks exactly like it looked on my command line. It's just a bit more complex here. So it fetches the pipeline definition, it executes a whole bunch of steps, and in this configuration, it will actually write the data to a SPARQL endpoint. And when you get the job succeeded, when the return code is 0, then everything worked well. And as you can see, the whole configuration with the passwords and everything is safely stored in the CI/CD variables in the Docker environment. So that's a completely other way of creating and launching a pipeline. This is now what the Environment Agency will start using for providing the pipelines. And what they do, the other company I mentioned, they create this visualization tool based on a RDF data cube JavaScript library we wrote. They can then go in there. It will now have a look at all data cubes which are on the endpoint available. I hope that works. That's the dev system. Cannot guarantee that it actually works. You should get a list of all data sets, and then it will walk you through visualizations. Like there are standard visualizations in there, and then the people get a link. Okay, the dev doesn't seem to work. I think it's resolved. Let me see if that one works. Oh yeah. So the not dev one works. So we have, for example, wood harvest in Switzerland. And the cool thing, you see, this is multilingual. This is available in 4 different languages in Switzerland. You get that in German, English, Italian, and French. And this is so easy to do with RDF. So now it will load it. This is our JavaScript library I mentioned. It gives you a little bit an Excel view from the same data. And then you can choose like what are the visualization types you want to have. Not sure what makes sense for that. You can add metadata. And in the end, they will get the permalink, which they can integrate in their content management systems. They can create SVG out of it. They can create PDFs out of it for publications, which they have to do, which they still do. And it's all driven by RDF. And the mapping was done in this interface, and the pipeline executed the transformation, created the metadata, and so on. I think that's it. Again, I will send you the link so you can play with that stuff. If you want to know more, just let me know. And let's use the last 10 minutes for maybe some more questions or some ideas.
Well, thank you so much, Adrian and Thomas. It's quite something you put together here. In the time remaining, do others have comments or questions or observations?
I guess I have this is Mark again. I mean, this looks amazing, and I'm instantly thinking about what sort of pipelines do our current clients have? That could be, and how complex are they compared to this? I mean, is there any? Does it require, I guess, GitHub usage to run the pipelines?
No, totally not. That's a very good remark. So this is another example. This is a customer where they have data which they want to publish as open data, but the data is coming from a completely locked down intranet, like no HTTP access, nothing. So what they did here, exactly same principle. So when you go in here, this repository is also public, by the way. This is basically the pipeline which runs, which is rather simple. And then I simply have a Docker file which builds a pipeline which is run by cron within the Docker container itself. So it's basically a cron-based Docker container, and it will simply execute the pipeline based on the schedule I defined in the cron tab file. And all I have to do, so the only thing I need to push to the customer is they need to have a Docker registry or open access to my Docker registry. We pull it from there, and then they can run that in the intranet without installing anything from the outside.
Nice.
So here, I didn't have Docker. This was running on my local system. Docker is simply a nice way of wrapping it, but you don't have to. Other colleagues run it on Windows with on Windows. You should install the, how is it called, the Linux subsystem.
Oh yeah, Linux subsystem for Windows.
Yeah, you don't want to use it with just plain PowerShell. So install the Linux subsystem, and then it feels like on my Mac here.
Nice.
That was a bit the idea. We don't have any other dependencies on like gigantic software pieces or something.
Yeah, that's great. I actually jumped in late. In terms of the flexibility for doing the mapping, I mean, most of our clients, we do significant ontology work, and so we obviously want to be able to craft the triples to match that ontology. I may have missed that. Is there a place where that kind of mapping actually happens?
Let me quickly show another approach. So the one approach is you really create these CSV on the web mapping files, but you don't want to write them manually. And the web interface you saw before only works for data cubes right now, so you cannot use it for generic mappings. What we then did, that's the only thing which is not open source, by the way, because we didn't really have too many people paying us for that yet. So we created a so-called domain-specific language, which is basically a mapping language, which gives you a way to map any data to RDF in an assisted way. I will quickly show you that. This is from the Swiss Railways. They have a ton of things they make public. So, for example, all the zones, like you will buy in Switzerland for regions like, what's the English word, abonnement, like subscription, or how do you call that you don't pay per trip, but you pay per month.
Yeah, subscription.
So, exactly. And then with the subscription, you have like a certain validity in certain regions. And Switzerland is really crazy about trains, so this is super complex. So they basically create files, CSV files, and in, let me quickly open it, the source, where's the source? You basically just are here. This is basically inspecting the source files and then telling like, okay, these are the columns in these files. So you can do, by the way, the same with relational database. This works for CSV files and RDBs right now. And then you define the vocabularies you want to have. This is also simply generated from, for example, schema.org or whatever. So this is all the DC terms namespace with the classes and the properties. And then you have a mapping language behind it. And you say, for example, I will quickly show you how it works with Code Assist. You say map, and you can do code assist now. So it really guides you through the process. I map something from this CSV file, and the subject template is that URI pattern.
Okay, yeah.
And then
Nice.
you go on, and you can map to the prefixes, and this is the table. Another cool thing is when you reference stuff which doesn't exist, for example, you have typo in here, it will notice it and tell you like this doesn't exist. Same for mapping to columns. And then what we generate out of that, we can generate R2RML mapping. Those of you who work with relational database know that. So
Nice.
you can directly map relational tables with it, or you can create CSV on the web output, or RML output for those who worked with the RML mapping language, which is a superset of R2RML. So this one initially only worked in Eclipse. Now we have a Visual Studio Code plugin, and we are actually have a proof of concept of a Theia. And I'm not sure if you know Theia. This is basically a web-based Eclipse. So you can deploy that in a container, and then the mapping is completely done in a web interface in the web browser. You don't need anything installed on your local system. So that's another abstraction we did because we didn't want to do that stuff manually. And we mapped complete Oracle databases with that. It's so much easier because you don't have to write R2RML manual anymore. It will figure out when you reference stuff which doesn't exist anymore, so you can really be very agile with the data and slowly move forward and extend it.
Very.
So, Alex had a question, and Alex, he can't use his mic today, but the question is, in a couple of words, what are the advantages of the RDF cube over the traditional ETL plus data warehouse plus Tableau?
So to be fair, I never worked with Tableau, so I don't really know how much Tableau supports you with the stuff. What our customers want is they clearly say, in some way, we want to build a web application which is our data. So that's the stuff we have to do as a government organization. But in another way, we want to also give direct raw data access to the people, because we don't know what kind of questions people might ask on our data. And we did that, for example, for the city of Zurich. Let me quickly see if I can still show you the queries. They did some super complex queries on their own data. They came up, the data owners, so the guys which actually maintain the data, came up with questions which they couldn't solve with, in that case, they had SAS or SAS, or however it's called. So they told me, like, it's basically impossible to do this query within SAS because it would go over too many different data. And in Sparkle, we could like combine a whole bunch of cubes, and we could create queries which went over 5, 6, 7 cubes, and it was super simple to do so. So I think it's when you really want to dig into the data and you want to ask questions no one thought of, RDF is the way to go, because that's the whole point of it.
Yeah, that's a good summary of the advantage. You all have some other tools. Before we let everybody go, I know that last year, for example, you had an ontology management tool. You've got accessibility, a browser for public ontologies, etc.
Exactly.
What's the high point that you want to hit? That just a takeaway that people just go visit your site and take a look at.
So basically, what interests us most, and you should really talk to me when this is of interest for you, we want to make sure that more people are capable of working with RDF and solving problems with RDF. And we think that a big part of the missing ecosystem is stuff for developers and people like you, which are domain specialists or RDF specialists, that you don't want to go through manually creating stuff. So everything we do is somewhat related related to that. So this ontology editor was done for domain specialists which don't want to know about OWL. You will not launch a protege here. You basically have a way of going in a big group into discussions about, is this property really necessary or not? You know, all these endless discussions you need to have. It's just basically an application around this development process. Think of schema.org for people who don't want to write triples. Then the prefix server, that's something we had. You saw before in this thing, in the Eclipse plugin, that I can autocomplete to terms. So we had to basically get commonly used vocabularies in a way that we can use that, which was unfortunately more complicated that we thought. A lot of ontologies will not be dereferenceable by default. So we simply created a repository which contains stuff, and now this Eclipse plugin can use the work we did in this prefix server, which in itself is maybe not super interesting, but you can then start building tools which are more intelligent with autocomplete. Or the autocomplete you saw in here, that's coming from exactly that service. So we build tools that make our life easier so more people can do the work we actually don't really want to do ourselves. We want to build the next step, the next step, the next step of the tooling, but we don't want to solve the problem 10 times for 10 different customers ideally. We want to solve it once, build the tools, and then make them available that other people can now do it for the rest of the customers while we are already at the next step for the next abstraction. And I'm more than happy to maybe in a few months show some other stuff which we are working on right now.
Yeah, it's much appreciated and much needed for sure. I'm sure the folks on the line who are familiar will appreciate exactly what you've done here. So thank you so much for talking about this and highlighting the important points of it, Adrian. And good to hear you guys are doing so well.
Yeah. Last thing, what should I do with the links? Should I send it to you, Alan, and you distribute it, or what's the best way?
Yeah, if you would send to Melissa and you can copy